Say the first application is tangents and normals, and we say if you have a curve, this curve has a point. At a given point, we have a straight line drawn to that point on that curve, and that's the last line is called a tangent. It's a straight line which is always in the form of y is equal to mx plus. Then at that particular point still on that curve where the tangent meets the curve, we have the normal, and the normal is perpendicular. Still the normal is a straight line, which is also y is equal to mx plus c, so straight line. So the question that can come out here is, since we are using differentiation, we know very well that when you differentiate the equation of the curve, you get the gradient of the curve at a particular point. So getting the gradient of the curve at a particular point, which is m, can enable us to get the equation of the line, which is either the normal or the tangent, depending. But you should remember that the gradient, if the gradient of the tangent is m1, the gradient of the normal is going to be m2, which m2 is the reciprocal or negative reciprocal of m1 because they are perpendicular lines. Now, we have an example. Find the equation of the tangent y cubed, let me write it here, y cubed plus y squared minus x power 4. This is equal to 1 at 1, 1. Now, this time around they are not asking for the gradient. This time around they are asking for the equation. So they want something in this form, y is equal to mx plus c. Now, we are going to start by differentiating, and we get to the gradient at that point. So we say d, we are differentiating this with respect to x plus, because this is this is an empty list also. On the previous video, we saw how to deal with such. This is x power 4 is equal to d dx. This is 1. When we differentiate this one, we shall have 3y squared, but we are differentiating the y with respect to x, so the y stays, and then plus 2y, drop that, reduce that 2 by 1, then the dy dx remains. This is minus 4x cubed. This is equal to 0. If you get a constant, you get a 0. I can get the dy dx factored out, and we stay with 3y squared plus 2y, and I take the 4x, negative x here, so it becomes a positive 4x cubed, like that. Then I want to get dy dx. Therefore, my dy dx is going to be 4x cubed. All of this is divided by 3y squared plus 2y. But we are getting our dy dx at a point which is 1, 1. So we come and substitute 4 times 1 cubed over 3, 1 squared plus 2, 1. This is equal to, this is a 4 over, this is 3 plus 2, which is a 5. So this is the gradient, but it is not the equation of the tangent. So how do we get the equation of the tangent? We can simply substitute in this formula. We say that change in y by change in x is always equal to the gradient m. We are considering this at a point which is, we are considering a point given which is 1, 1. Then we are also introducing our point xy. So change in y by change in x is the y value minus the y value over x value minus the x value. This is the change in y by change in x. I'm substituting for this. This is equal to m, which we have as 4 over 5. When I cross multiply, I'll have 5y minus 5 being equal to 4x minus 4, such that 5y is equal to 4x plus 1. So this is the equation of the tangent to this curve at that point.